Let's take a look at solving exercise 6.5.7. Here we want to solve the rational equation if there is a solution, and if there isn't, we want to say that as our answer. 6 over z minus 9 over x over z minus 2 equals 1 over 7. So first we want to set up our restrictions lists by setting the denominators with the variable not equal to 0. So if we take that first denominator, we see that z can't be 0. The second denominator, z minus 2 can't be 0, gives us that z can't be 2. So those are our restrictions. If one of these values shows up as a proposed solution, we will have to reject it. Now let's find the LCD. In the first denominator we have a z, so that has to be a factor in the LCD. In the second denominator we have a factor of z minus 2. That has to be a factor in the LCD. In the third denominator we see a factor of 7. That also must be in the LCD. So the LCD has the three factors, 7, z, and z minus 2. So we are going to take that LCD and multiply it by each term of the equation. So 7z times z minus 2 gets multiplied by 6 over z. 7z times z minus 2 gets multiplied by 9 over z minus 2. And 7z times z minus 2 on the other side of the equation gets multiplied by 1 over 7. So in the first product, the z's divide out. In the second product, the z minus 2's divide out. And in the third product, the 7's divide out. So in the first position, we're left with 7 times z minus 2 times 6. And we can put that 6 in front of the 7. We can multiply in any order. Second product leaves negative 7z times 9. And we'll just put the 9 in front of the 7z. And the third result gives us z times z minus 2 times 1. And let's go back to the first product. And we have 42 times the difference, z minus 2, minus 63z equals z times z minus 2 times 1, which is just z times z minus 2, which is z squared minus 2z. So distributing, we get 42z minus 84 minus 63z equals z squared minus 2z. Let's combine the like terms on this left side, and we get minus 21z minus 84 equals z squared minus 2z. Let's add a plus 21z and a plus 84 to both sides of the equation. And the left side becomes 0, and the right side becomes z squared plus 19z plus 84. And we can switch the left and right side. Doesn't matter which expression is on the left and which is on the right. So let's put the z squared plus 19z plus 84 on the left and the 0 on the right. And we can factor this trinomial as z plus 7 times z plus 12. So 12 times 7 is 84, and then 12z plus 7z is 19z. So the only way this product is going to be 0 is if z plus 7 is 0 or z plus 12 is 0. So let's add a negative 7 to both sides of the first equation and negative 12 to both sides of the second equation. The first equation gives us z equals negative 7. The second equation gives us z equals negative 12. Neither one of these is on our restriction list, which contains z equals 0. Z could not equal 0, and z cannot equal to 2. So neither of these is 2 nor 0, so we can accept them both, and this is our solution set, the set containing negative 12 and negative 7. And notice you answered 7, 12. The correct answer was negative 12 and negative 7. And the order doesn't matter. You could have written negative 7 and negative 12, as long as one of your solutions is negative 7 and the other is negative 12. It does not matter what order you write them in. This is not an ordered pair. It's a set. In sets, order does not matter. All right, so we have the correct answer.